Hello students, and welcome to this lesson on trigonometry. Our objective today is that we will apply trig ratios to find missing sides and angles using our journal notes and practice problems. So just a quick review of what we did yesterday, let's just talk about our trig ratios and what they actually are. So if I'm working with this angle theta, then the trig ratio is going to be a relationship between theta and some of the sides. And this is of course always in a right triangle. So first off, let's identify what each of our sides are in relation to theta. So for instance, always the longest side of our right triangle is going to be our hypotenuse, and then that leaves the other two sides to be our legs. And then between our legs, we have to orient ourselves towards theta. So the leg which shares a vertex with theta is going to be your adjacent leg. Then your leg, which does not share the vertex, will be your opposite leg. So I'm just going to use these abbreviations from now on, O, A, and H. But whenever I say O, A, or H, I'm going to be actually meaning opposite, adjacent, or hypotenuse. Now, for the sine function, yesterday we learned that sine theta is going to be the opposite over the hypotenuse. So that's the length of the opposite side over the length of the hypotenuse. For cosine, we learned that the adjacent leg, the length of that over the hypotenuse will give me my cosine, and for tangent, it's going to be my opposite over my adjacent side. All right, and so between these, what we have is this nice little memory device where if you want to memorize these, probably the easiest way is to give yourself a memory device like this. But the one that I used growing up was SOHCAHTOA. And it's kind of a weird sounding word, but it's got all of your letters in here, right? Sine is the opposite over hypotenuse. Cosine is the adjacent over the hypotenuse. Tangent is the opposite over the adjacent. So if you can just remember that, that will help you a little bit with these. Now, the hardest part, in my opinion, of trig is remembering to use the right pieces in the right places. All right, so now we're familiar with actually what our trig ratios are. Let's see what it looks like to apply them to a problem. Now, before we go any further, make sure that you have a graphing calculator, one of our yellow school calculators, and make sure that it is in degree mode. So what you're going to do when you turn your calculator on, you're going to press the mode button. Now from there, you'll be in a menu. In that menu, the very first thing that you see is that you're blinking on normal. What you're going to want to do is scroll down twice until your cursor is on top of the word radian, and then scroll over to the right to degree and go ahead and press enter. So then your calculator will be in degree mode. Now that just tells you the mode which your calculator will be measuring angles in. And most of the time we're going to use degrees, so go ahead and just make sure that it's in degree mode each time that you start it up. Alright, so just like our homework last night, in example 1, we're going to be looking for a missing side length given an angle measure and another side. So let's go ahead and set up our ratio and how it'll look. Well, first, which ratio are we going to use? Well, we have this angle here, right, this 40 degrees, and I'm given which two sides? This 8 represents the adjacent side, and this x represents the opposite side. So I have opposite, I have adjacent, and I have the angle measure of 40. All right, well, let's see which ratio we're going to use. SOHCAHTOA. Tangent has the opposite and the adjacent in it. So I'm going to say tangent of 40 degrees is equal to, and then opposite over adjacent, so that's going to be x over 8. Now, this is just an algebra problem. So what we're going to discover is that whenever you have something like tangent of 40, that's just a number. So you can actually just input, on your calculator, you have 3 buttons, right? And that's the sine, the cosine, and the tangent function. And what you can say is input tan and then input 40, and it'll just spit out a number for you. So that's just some number. So we can perform algebra with it. So let's go ahead and perform that algebra. So I want to get x by itself, so I'm going to multiply both sides by this 8 here, and I get 8 times the tangent of 40 is equal to x. And then we plug that into our calculator and we plug in tangent of 40. And tangent of 40 is approximately 0.8391. So that's just the number. And then we're multiplying by 8, and then that will give us x. And so we get that x is approximately 6.71. So this side length over here, this x, is going to be about 6.71. All right, so let's do example 2. So example 2, again, we're going to be using our tangent function. So we've got our adjacent here, and we have our opposite. Okay, so now we're going to be setting up tangent. Here, let me draw a little line here between the work that we're doing on these problems. All right, so we're saying the tangent of 42 degrees is equal to the opposite over the adjacent. So this is going to be 9 over x. And this is where our algebra is going to be a little bit different. We went into this yesterday a tiny bit. So remember, one thing that you can do is just multiply both sides by x, and you get x tangent of 42 is equal to 9. And then from there, you can divide both sides by the tangent of 42, and that should give you your answer. So here we get x is equal to 9 over the tan of 42. And if we plug this into a calculator, we see that the tangent of 42 is going to be 0.9004. So this is x is equal to 9 divided by 0.9004. And then x is approximately going to be 9.99. Well, actually, there's a 5 in here, so let's go ahead and round this up. So this is going to round up all the way to 10. All right, so this missing side here is going to be 10. That's going to be x. So finding sides is relatively easy. But what about if we're missing our angles? So our calculator is actually really helpful in this case. Remember, whenever you're working with sine, cosine, and tangent, they're just functions. And like you learned in Algebra 2, functions are really just something that you are doing to an input, right? And what we know is that we can find an inverse of any given function. So our calculator has the ability to use our inverse sine, inverse cosine, and inverse tangent. So on your calculator, you notice that you have some blue menu options. So if you look at the sine, cosine, and tangent button, you notice that in blue above it, you have sine -1, you have cosine -1, and you have tangent -1. So to access those functions, what you're going to do is press the second button, and then if you want sine -1, you press sine. And then you see in your calculator, the sine -1 function will appear. So that's going to be important to us when we start doing this next problem. All right, so I'm looking for some missing angle value here. Well, we're going to also use another trigonometric function or a trigonometric ratio to solve for this. So let's see which one we want to use. So I have my adjacent piece here, and I have my hypotenuse here. So I have my adjacent, my hypotenuse. Oh, okay, so I'll use my cosine. So I've got cosine of x is equal to the adjacent over the hypotenuse. So that's going to be 7 over 25. Now you notice, if I want to get x by myself, I have to get rid of this function here. I have to get rid of cosine. So to get rid of cosine, what I'm going to do is multiply it by the inverse function. So you guys know inverses, right? If you know that something is x squared, the way that I get rid of the square is that I would say square root x squared is equal to x. So those are inverse functions, square root of x and x squared. And the same thing is going to happen up here. So the inverse of cosine of x is the, well, we call it the arc cosine, but it's the inverse cosine. So what we're going to do is multiply both sides by the inverse cosine, or take the inverse cosine of both sides. So I'm going to just pull down a little bit here. So cos -1 of cosine of x is equal to the cos -1 of 7 over 25. Okay, so this function and this function cancel out, and I'm left with x on this side, and that's x is equal to the arc cosine of 7 over 25. All right, and what's really cool about this is that this is something that I can just plug straight into my calculator. So when we plug the arc cosine of 7 over 25 into my calculator, all I get is my output. And you get x is equal to 73.74. And this is going to be in degrees because x is, in fact, a angle measure here. All right, so let's do the same thing for our example number 4. What I'm going to do is I'm actually going to move my example 4 onto a new page, but just continue going down the line here. All right, so for example 4, we're going to just finish up here. So we have to determine which function we want to use first, right? So here I have my opposite side, and I have my hypotenuse over here. And I'm looking for some missing angle. So opposite and hypotenuse, well, that tells me to use sine, right? Because so katoa. So sine of x is equal to 28 over 53. And then the same thing will happen here is we're just going to take the inverse sine function of each side, and that's going to strip this sine function out. So we have the sine -1 of sine of x, and that's going to be the sine -1, or arc sine, of 28 over 53. And again, the beauty of this is the fact that this seems like it's complicated at first glance, but the reality is that this end result that we're getting here is something that I can plug directly into a calculator and get an output. So we're gonna say the sine -1, or the arc sine, of 28 divided by 53. And what I get is I'm going to have 31.89. So x is approximately 31.89 degrees. Again, because x is a angle here, we need to make sure that we're notating that it's degrees and not some type of length. All right, so